Okay, Assalamualaikum to all of you. Welcome back to our class. Today, we continue on this module, module 6 regarding NAT for IPv4. Right, so this slide you can get from our e-learning, and also as usual after this, I will activate a few or couple of exercises using packet tracer in our e-learning, right? Okay, objective of this module, since this is a NAT, for IPv4. Okay, module objective, configure NAT services on the edge router to provide IPv4 address scalability. Okay, topic under this module, we have NAT characteristic, type of NAT, NAT advantage and disadvantage, static NAT, dynamic NAT, part, and also NAT for IPv6, NAT characteristic. Okay, IPv4 address space, Networks are commonly implemented using private IPv4 addresses as defined in RFC document 1918, document reference. You can see that. So A, B, and C, our class UTM in B, 161, 16, that range, UTM IP address, class B. Okay, private IPv4 addresses cannot be routed, over the internet. Used within an organization or site to allow devices to communicate locally. Okay, to allow a device, private IP, all right. To allow a device with private IPv4 address to access devices and resources outside of the local network. The private address must be first translated to public address. So because of that, NAT provides the translation of private addresses to public addresses. Right. So what is NAT actually? The primary use of NAT is to conserve, public IPv4 addresses. Okay. Actually, in here in Malaysia, we still conserve this IPv4. In many applications, we still using this. So now NAT is very important. So that's the primary purpose. So NATs allow networks to use a private IPv4 addresses internally and translate them to a public address when needed. So these are another purposes. A NAT router typically operates at the border of a stub network. When a device inside the stub network, wants to communicate with a device outside of its network, the packet is forwarded to the border router, which perform the NAT process, translating the internal private address of the device to a public, outside routable address. Okay. Okay, we have, you can see here, okay, this is private IP, okay, which is connected to R1 and it goes to R2. Okay, this is the server. So all these need to try to access this server. And also we want to see that how this from, wait, this one, okay. This is a pen. Okay, no problem. Okay, we want to see how the packet travel from PC1 here to server, and also from server to back PC1. and what is the value they change, what is the IP address they are using. Okay, that's very important. We want to see that. Okay, right. So how NAT works? Yeah, PC1s. Yeah, PC1. Where is PC1? Okay, this is PC1. Yeah, PC1. This is the server. Okay, okay. PC1 wants to communicate, yeah, with an outside web server with public address 209.165.201.1, which is here. Yeah, this. Yeah, from here to here. Okay, here we have, you can see here, routing, not routing, is a NAT table. Okay, in R2. Okay, PC1 send a packet addresses. Yeah, packet address to the web server. Okay, packet address PC1 here. And then R2 receive here. Yeah, R2 receive the packet and reads the source IPv4 address to determine if it needs translation. Yeah. And next, R2 adds mapping, okay, of the local to global address. Okay, local to the global address. Yeah. Okay, from mapping of the local to global address to the NAT table. Okay, so to the NAT table in here. Yeah. And then R2 send the packet with the translated source address towards the destination. Okay. And then the web server respond with a packet address to the inside global address, which is for PC1 is 209.165.200.226. Okay, inside global back web server respond in here. Okay. So R2 receive the packet, yeah, with destination address 109.165.200.226. Yeah. And then R2 check the NAT table and find an entry for this mapping. Okay, check, and then there is a mapping. R2 use this information and translate the inside global address. Yeah, inside global address, which is 209.165.200.226 here. Okay, to the inside local address. Inside local address, which is 192.168.10.10, which is here. And the packet after the change or replace, and the packet is forwarded back to words PC1. Yeah. Right. So NAT terminology. NATs include four types of addresses: inside local address, inside global address, outside local address, and outside global address. NAT terminology is always applied from the perspective of the device with the translated address. Okay. Okay, inside address, yeah, inside address. Inside address is the address of the device which is being translated by NAT. Okay. Outside address is the address of the destination device. Yeah. Local address. Okay. Local address is any address that appear on the inside portion of the network. Okay. And then what is a global address? A global address is any address that appears on the outside portion of the network. Okay. Right. Inside local address. Right. Inside local address. Inside local address, Okay, is the address of the source as seen from inside the network. Yeah, this is typically a private IPv4 address. This inside local address of PC1 is 192.168.10.10. Okay. All right, where is it? Here, PC1. Here. Okay. Inside local address. Okay. Okay, the inside global. Okay, inside global addresses. The inside global address of source as seen from the outside. Yeah. The inside global address for of a PC1 is 209.165.200.221. Yeah, inside global. Yeah, in here, inside global. Okay, inside local here, inside global here. Okay, SA is a source and SA here, DA is destination address. Okay, outside global. Yeah, the address of the destination as seen from the outside network. Okay, the outside global address of the web server is 209.165.201.1. Yep. Okay. Okay, that one for outside global address. Okay, outside global. This one outside global for here, outside global. Yeah. Outside local. Okay, the address of destination, which is here. Okay, the address of the destination as seen from the inside network. PC1 sends traffic to the web server at the IPv4 address 209.165.201.1. Okay, now the traffic goes from PC1 to here, from client to server. Okay, and then with address 209.165.201.1. Okay, all right. While uncommon, this address could be different than the globally routable address of the destination. Yeah. Okay. And also this one, when they goes here, so you can check this one outside global. Okay, inside global. Oh, they didn't change. Okay. This one outside local, same inside local, and the traffic goes from here. Okay, all right. The type of NAT. Okay, first type is static NAT. Yeah, static NAT use a one-to-one mapping of local and global addresses configured by the network administrator that remain constant. Static NAT is useful for web servers or devices that must have a consistent address that is accessible from the internet, such as web server company. Yeah, all right. It also useful for devices that must be accessible by authorized personnel when offsite, but not by the general public on the internet. Okay, and then this is very important, which okay, static NAT require that enough public addresses are available to satisfy the total number of simultaneous user session. Okay, so let's say if we have a multiple access to the server, so that we need to provide enough public addresses. Yeah, we cannot maintain with this static IP only one, similar to others. Yeah, if we goes for dynamic later on, similar. So we need to provide specific IP. Yeah, IP address for each of the connection or for the client. Okay, that's the fundamental concept. Okay, when they are communicating. All right. So dynamic NAT, another type. So dynamic NAT use a pool of public addresses, yeah, and assign them on a first come first serve basis. Right. When the inside device requests access to an outside network, dynamic NAT assign an available public IPv4 address from the pool. Okay, all right. The other addresses in the pool are still available for use. Okay, right. Okay, like this example, inside local, this one inside global address pool. Okay. And then note dynamic NAT require that enough public addresses are available to satisfy the total number of simultaneous user session, similar for static. Okay. All right. Port address. Okay, the port address translation or PAT, yeah. PAT, also known as NAT overload, yeah, maps multiple private IPv4 addresses to a single public IPv4 address or a fewer addresses. With PAT, when the NAT, okay, router receive a packet from the client, it uses the source port number to uniquely identify the specific NAT translation. Okay, PAT ensure that devices use a different TCP port number for each session with a server on the internet. Okay, so where is the part here? So there is a port address here, translation at the back colon, and also there's the address for the, we call that port, yeah, port address translation or part. Okay, so type of NAT next, which is next available port. Okay, ports attempt to preserve the original source port. If the original port, yeah, is already used, port assign the first available port number starting from the beginning of the appropriate port group. We have a couple of group here. Okay, 0 to 511, 512 to 1023, and the rest is to 1024 until the whole IP, the whole port number, which is 65,535. Okay, when there are no more port available and there is more than one external address in the address pool, part move to the next address, try to allocate the original source port. Yeah. Okay, the process continue until there are no available, yeah, no available port or external IPv4 addresses in the address pool. Okay. NAT and PAT. Compare summary of the differences between NAT and PAT. NAT only modify the IPv4 addresses. PAT modify both IPv4 address and also the port number. Okay. So NAT one-to-one mapping between local and inside global addresses. PAT, one inside global address can be made to many inside local addresses, right? Okay. Port reflect to the applications. Which application? Sometimes many user will access the same application. That's why we need to have this port address translation or PAT. Uses only IPv4 addresses in translation process. Okay. Use IPv4 addresses and also TCP or UDP source port numbers in translation process. A unique inside global address is required for each inside host accessing the outside network. A single unique inside global address can be shared by many inside host accessing to the outside network. Yeah. Right. Okay. Okay, packet without layer 4 segment. Some packet do not contain layer 4. This one some extra info. Layer 4 port numbers such as ICMPv4, version 4 messages. Each of these types of protocol is handled differently by part. For example, ICMPv4 or version 4 query as messages, echo requests, and also echo reply include that a query ID. ICMP, SMB for users the query ID to identify an echo request with its corresponding echo reply. So note other ICMPv for messenger do not use the query. These messages and other protocol do not use TCP or the UDP port. Numbers vary and are beyond of the scope of this curriculum. Okay, because we're not covering on this IPv4 actually. ICMPv4, we use supporting for this ICMP version 3 only. All right. Okay, NAT and also advantages and also disadvantages. So advantage of NAT. NAT provide many benefit. NAT conserve the legally registered addressing scheme by allowing the privatization of intranets. NAT also conserve addresses through application port level multiplexing. NAT increases the flexibility of connection to the public. And also NAT provide consistency of internal network addressing scheme. NAT allow the existing private IPv4 address scheme to remain while allowing for easy change to a new public address scheme. NAT also hide the IPv4 addresses of users and also other devices. So disadvantages of NATs. NAT does have drawbacks such as NAT increases forwarding delay. End-to-end addressing is lost. End-to-end IPv4 traceability is also lost. NAT complicates the use of tunneling protocols such as IPsec. Services that require the initial, initiation, or initials for TCP connection from the outside network or stateless protocols such as those using UDP can be disrupted. Okay, so some cases we need to see this because these are some disadvantages of this NAT. Okay, static NAT. Okay, static NAT scenario. Static NAT is a one-to-one mapping between an inside address and an outside address. Static NAT allow external devices to initiate connection to internal devices using the statically assigned public address. For instance, an internal web server may be mapped to a specific inside global address so that it is accessible from outside network. Okay, so this is from this client try to accessing using static NAT translation. All right, so next, configure static NAT. There are two basic tasks when configuring static NAT translation. First step is creating a mapping between the inside local and also the inside global addresses using the IP NAT inside source static command. Step 2, the interfaces participating in the translation are configured as inside or outside relative to NAT with the IP NAT inside and also IP NAT outside. Sorry, for IP NAT inside and also IP NAT outside. For example, in this, yeah, we do setting. Okay, so first IP NAT inside source. Okay, okay, we set that, and then interface serial. Okay, IP address and the subnet address, and then IP NAT inside, and then exit, and then interface serial for that particular interface, and then set the IP address, and also we setting the command IP NAT outside. Okay, for that, for another side. Okay, for the inside and then for the outside. All right. Okay. Okay, analyze static NAT. The static NAT translation process between the client and the web server. Yeah. The client send a packet to the web server. Okay. Number one, client. Okay, in here. R2 here receive packet from the client on its NAT outside interface. Okay. So outside interface, which is here. Okay. And check is NAT table. So this is the NAT table at R2. Okay. Right. And then R2 translate the inside global address of the inside local address and forward the packet towards the web server. Okay, R2 translate, yeah, the inside global address of to the inside local address and forward the packet towards the web server. Next, the web server receive the packet and respond to the client using its inside local address. Okay, fourth step here. And then at 5A in here, so R2 received the packet from the web server on its NAT NAT inside interface with source address of the inside local address of the web server in here. Okay. And then translate the source address to the inside global address in here. Okay. After that, to verify NAT operation using the show IP NAT translation command. Yeah. This command shows active NAT translation because the example is a static NAT configuration. Yeah, the translation is always present in a NAT table regardless of any active communications. If the command is issued during an active session, the output also indicates the address of the outside device. Okay, show IP NAT translation, and then we check that. Okay, the IP inside global and inside local, and then show IP NAT translations. Then can see this for outside local and also outside global. Yeah, so this is how we verify this NAT. And then another useful command is show IP NAT statistics. Right. And then it display information about the number of active translation, NAT configuration parameter, the number of addresses in the pool, and the number of addresses that have been allocated. To verify that the NAT translation is working, it is best to clear statistics from any past translation using clear IP NAT statics command before we do testing. All right, dynamic NAT. Okay, shall we stop here for a while and I will come back to you, yeah? Okay, so dynamic NAT. Okay, dynamic NAT automatically maps, yeah, inside local addresses to inside global addresses. Yeah. Okay, dynamic NAT use a pool of inside global address. Okay, the pool of inside global addresses is available to any devices on the inside network on first come, first serve basis. Okay. If all addresses in the pool are in use, a device must wait for an available address before it can access to the outside network. Okay. So all this will get the IP address through automatic, yeah, plug and play, so they will get the address. Okay. Configure dynamic NAT. There are 5 tasks when configuring dynamic NAT translation. Step 1, define the pool addresses that will be used for translating using IP NAT pool. Yeah. And then standard ACL to identify or permit only those addresses that that are to be, yeah, that are to be translated. Step 3, bind. Okay, the ACL to the pool using IP NAT inside source list. Yeah. Okay, IP NAT pool. Okay. So this we define the addresses that will be used for translating. Yeah. This one you can highlight. Okay, this one. Yeah. Yeah. All this the range and this is net mask. Okay. And then configure the SCL standard, yeah, SCL standard to identify only or to permit only those addresses that are to be translated. Yeah. And bind that SCL to the pool using IPNet inside source list. So IPNet, yeah, inside source list, yeah, one, pool NAT, pool one. Okay. All right. Configure dynamic NAT. So sorry, there are 5 steps. Next step, there are 5 tasks when configuring dynamic NAT translation. Identify which interface are inside. So you need to determine and then identify which interfaces are outside. Okay, after that, so we apply on that. Okay, interface and IP NAT inside goes to that specific correspond interface, and then we do setting IP NAT outside. Okay. Analyze dynamic NAT. Okay, inside to outside. Yeah. Okay, here dynamic NAT translation process. PC1 and PC2 send packet requesting a connection to the server. Okay, PC1 and PC2. We have 2 PC. Okay, right now. Both are requesting a connection. Yeah, incoming access to the server. So next, number 2 is number 2 in here is the okay, R2. Okay, R2, you can sorry, you can check this. Okay, number 2 here. IP address for the each of these PCs. Yeah. So R2 receive the first packet from PC1. Okay, R2. This router will receive PC1. Yeah. PC1 first. Yeah. And check the SCL to determine the packet should be translated. And let's see. Let's see. Let's check the LC. Yeah. Check the NAT to determine if the packet should be translated. Yeah. Select an available global, yeah, address and create the translation entry in the NAT table. Okay. All right. And then R2 replace. Yeah, up to that. R2 replay after the check, and then replay the inside local address of PC1, okay, which is 192.168.10.10 here, with the translated inside global address, which is 209.165.200.226 here. And forward the packet to the destination. Okay, the same process they did for PC2 as well. Yeah, PC2 using the translated address of, so they will get this IP. Yeah, inside global, which is 209.165.200.227. Okay, this one for next IP address, which is come from PC2, which is this one. Yeah, 192.168.11.10. Okay. Okay, this one from outside to inside. Okay, outside to inside. Okay, the server respond. Yeah, the server receive the packet from PC1. Okay, PC1 and respond using the destination address of 209.165.200.226. Okay, the server receive packet from PC2. It respond to using the destination address, which is 209.165.200.227. Okay, this one. And then 5A in here. Okay, when R2 receive the packet with the destination address of 209.165.200.226, yeah, it perform a NAT table lookup. Okay, and then translate the address back to the inside local address and forward packet towards PC1. Yeah, okay, yeah. Come back to here, they check, then they will change. Okay, here, check, and then goes to this. Yeah. Okay, when R2, yeah, 5B in here, yeah. When R2 receive the packet with the destination address of 209.165.200.227, it perform a NAT table lookup and translate the address back to the inside local address, which is 192.168.11.10, and forward the packet towards PC2. Okay, this is how they're using a dynamic NAT. Okay, and then finally PC1 and PC2 receive the packet and continue the conversation. The router performs step 2 to 5 for each packet. Yeah. Okay, the output of the show IP NAT translation command display all static translation that has been configured and any dynamic translation that has been created by traffic. Yeah, you can verify using this command. Adding the verb was, yeah, keyword display additional information about each translation, including how long ago the entry was created, yeah, and also used. Yeah. So some extra info when we put on verbose keyword. Yeah. By default, a translation entries timeout after 24 hours, unless the timer has been reconfigured with IP NAT translation timeout. Yeah. In global config mode to clear dynamic entries before the timeout has expired, use the clear IP NAT translation in privilege exec mode command. Okay, this one for clear IP NAT and show IP NAT. Okay, so when they type clear IP NAT translation, star means clear all dynamic address. Okay, clear IP NAT translation inside. Okay, global IP, local, and or local. So it will clear a simple dynamic translation entry containing an inside translation or both inside and outside translation. Yeah. So clear all extended dynamic translation entry. So clear IP NAT translation. Okay, protocol, which, and then inside global. Okay, we have global port, global IP, and local port. Okay, this. Okay, including the protocol. This one for inside, this one for global. Okay, this one to do a deleting or resetting. To show IP NAT static command, display information about the total of active translation. Yeah. NAT configuration parameter, the number of addresses in the pool, and how many of addresses have been allocated. Right. The show running config command and shows the NAT ACL interface or pool command with required value. Okay. Show running config and then put the part include NAT. Okay, they will give some info about the NAT. Okay, part. Configure part to use a single IPv4 address. To configure part to use a single IPv4 address, add the keyword overload to the IP NAT inside source command. Okay. In the example, all hosts from network 192.168.0.0 with subnet mask 16. Okay, matching SCL1 that send traffic through router R1 to the internet will be translated to IP address 209.165.200.225. Okay, at the interface S11. Yeah, procedure. The traffic flow will be identified by port number in NAT table because the overload keyword is configure. Yeah. Okay. All right. Yeah. Configure part to use an address pool. An ISP, Internet Service Provider, may allocate more than one public IP address to an organization. In this scenario, the organization can configure part to use a pool of IPv4 addresses for translation. To configure part for a dynamic NAT address pool, simply add the keyword overload to the IP NAT inside source. Okay, in example, NAT pool 2 is bound, is bound to an SCL to permit this IP, 192.168.0.0 to be translated. This host can share an IPv4 address from the pool because part is enabled with the keyword overload. Okay. All right. Okay, analyzing part. Okay, server to PC. PC1 and PC2 sends a packet to server 1 and server 2. Okay. The packet from PC1 reaches P2 first. Okay, R2 first. And R2 modify the source IP address to 209.165.200.225, which is inside global address. Okay, yeah. And then R2 from here to here. Okay. And then the packet from PC2. 4.15. Okay, the packet from PC2 arrive at R2. Okay. Okay, part changes the source IP address of PC2 to the inside global address, which is this IP 209.165.200.225. Okay, PC2 has the same source port number. Okay, right. Okay, has the same source port number as translation for PC1. Okay, same port. You look here, this one. Okay. Okay, part increment the source port until source port number until it is a unique value in its table. Okay. In the example, we use 1445. Okay. All right. And then PC to server. Yeah, PC now to server. Okay, PC1 and PC2 send a packet. So now PC1 reach first, yeah, at R2. And then R2 modify the source IPv4 address to 209.165.200.225. Yeah, 225. Mm-hmm. Okay. 225, which is 225. Okay, in here. Okay, after that, the packet is then forwarded after they change. Okay, the packet from PC2 arrive at R2 and pad changes the source IP address of PC2 to the inside global address. Okay, 209.165.200.225. PC2 has the same source port number as the translation of PC1. Part increment the source port number until it is unique value in its table. In this instance, which is 1445. Yeah, PC2 server. One second, yeah. I have to pause. Right. Okay. Okay. So this one for PC to server. Right. And then server to PC. Yeah. Okay, the server uses the source port from the receive packet as the destination port. Yeah. And the source address as the destination address for return traffic. Okay. And then R2 changes the destination IPv4 address of the packet from server 1 from 209.165.200.225, yeah, to 192. Okay, 168.10.10. Okay, yeah. And then R2 changes the destination address of packet from server 2, okay, from 209.165.200.225, yeah, to the 192.168.10.11, yeah, and modify the destination port back to its original value, which is 1444, yeah, and then the packet forward to the PC2. Okay, all right. Verify the part. Okay, in order to verify this, use this command show IP NAT translation. Okay, it will display the translation between two different hosts, two different web server. Okay, notice that two different inside hosts are allocated the same IPv4 address. Yeah, which is 219.165.200.225 inside global. The source port number in the part table differentiate the two transaction. Okay, verify part. The show IP NAT statistic command verify the NAT pool, yeah, has allocated a single address for both translation. Also shown the number and type of active translation, NAT configuration parameters, the number of addresses in the pool, and how many have been allocated. Yeah. Okay, show IP NAT statistic to verify all the NAT setting. Okay, NAT 64. What is this NAT for IPv6? IPv6 was developed with the intention of making NAT for IPv4. Yeah, with translation between public and also private IPv4 addresses unnecessary. However, IPv6 does include its own IPv6 private address space, yeah, unique local address or ULA. Okay, IPv6 unique local addresses or ULA are similar to RFC 1918, yeah, private addresses in IPv4 but have a different purposes, right? ULA addresses, okay, are meant for only local communication with a site. ULA addresses are not meant to provide additional IPv6 address space, nor to provide a level of security. IPv6 does provide a protocol translation between IPv4 and IPv6 known as NAT64. Okay. NAT for IPv6 is used in a much different context with NAT for IPv4. The varieties of NAT for IPv6 are used to transparently provide access between IPv6 only and IPv4 only network as shown here. It is not used as form of private IPv6 to global IPv6 translation. NAT for IPv6 should not be used as long-term strategy, but as temporary mechanism to assist in migration of IPv4 to IPv6. All right. Okay. That's all for today lecture.